Hello, I'm Ray Fang, and I represent the Sensors Business Group under the electronics arm of ST Engineering. In this presentation, I will run through some background of typical commercial radar sensors, what it can do, what kind of information you can squeeze out of it, what are some of the advantages of radar sensors, before moving on to some applications and demos, before ending with a discussion. Just a little bit of history behind our business. We started designing and selling sensor modules since 1997 under the brand name AgileSense. And just this year, we are known as Agile Smart Sensors. Under the Agile brand name, we carry both microwave radar sensor modules and microwave radar sensor solutions. In this way, we can serve both OEMs and system integrators well, depending on their requirements. Till date, we are one of the few radar sensor suppliers in the world that carry sensor modules to cover the three main ISM bands, C, X, and K bands, where the C and the K bands are globally compliant and accepted. Though the X band is not considered a globally compliant band, it is still widely used in major markets such as the US, Europe, China, Australia, and many parts of Asia. And it still remains one of our largest revenue drivers. Both pillars, the solutions and the modules pillars, are both growing rapidly and both in parallel, with our optical detection radar being our latest addition under our sensor solutions. This solution is developed to be super lightweight, compact, low power, and priced competitively. At the moment, our largest markets still come from the US and Europe, including UK, with Asia and South America steadily catching up in the use of such sensors in the recent years. This could be because of the increase in tech expertise in using radar sensors in these countries. So what kind of information can we squeeze out from commercial microwave sensors? Traditionally, we know radar to be costly and used mainly in military, where they have a rotating antenna that's monitoring the surroundings for objects in range. These days, we have made it very, very cost-effective to be able to be mass deployed as a commercial or consumer product even. In the most basic form, they can sense motion and measure speeds very accurately via the Doppler principle. It's able to tell if an object is moving towards or away from the sensor, has ranging capabilities to a significant long range, and is able to identify the angles of incoming targets within the sensor's field of view. And all these pieces of information can be obtained simultaneously in a single scan without moving mechanical parts. Our customers rely on our sensors for various advantages. As you can see in this picture of our optical detection radar, it is able to detect obstacles through most plastics with little attenuation. This allows it to be easily waterproof and used in the outdoors. There is no visible lens, so people do not feel and do not know that a particular space is being monitored. Commercial radar sensors are also safe as they follow global spectrum regulations, limiting their power to milliwatts range. To put it in perspective of other high-frequency devices, your typical mobile phone emits 1 to 2 watts of microwave power. Your microwave oven emits 1,000 to 2,000 watts of microwave power. But these commercial radar sensors, they emit just in the range of 0.1 watts of power. Even technologies like LiDAR emit strong lasers that have been reported to damage digital cameras. Radar sensors also perform well in extreme environments, especially in environments with lots of variation in visibility. For example, when there is unpredictable fog, sand, dust, rain, vision systems tend to fail, but that's not the case for radar sensors. As compared to other sensor technologies such as ultrasonic or passive infrared sensors, radar sensors are also able to make better sense of its surroundings, providing lots of data in a single scan within a compact package. Because of these capabilities and advantages of radar sensors, they're being widely used in many applications for security, lighting, touch-free or contactless applications, parking, traffic management and monitoring, mobility, healthcare, drones, robots, and automation. In security, they are used a lot in indoor intrusion detection and outdoor perimeter protection. In recent years, we see more and more use cases in event-triggered CCTVs to save on back-end hard disk space, intrusion-triggered lighting, and outward-looking radars to secure fence lines. In these cases, our obstacle detection radar is a great candidate, as it will reduce false positives significantly as compared to the plain motion sensor types. For mobility, radar technology is usually preferred over other technologies because they are easy to deploy. They suffer low mechanical wear and tear, and they continue to operate even in bad weather. In recent years, sustainability has been a hot topic, and lighting has turned out to be a huge energy waster, especially during lull periods. So radar sensors have been very popular to dynamically turn on and off lighting as and when necessary. This is mainly because they are flexible to install indoors or outdoors. Autonomous robots that require some form of collision avoidance or warning system can also make use of radar-based sensors. This will provide added reliability as compared to infrared or ultrasound systems in the outdoors. Our obstacle detection radar was designed specifically for drones. We have made it less than 40 grams, and this includes a connected cable, and uses only less than 1 watt of power. Currently, I dare say that it is the only radar sensor in this class that is able to see more than 20 targets with range and angle information simultaneously in its field of view. This application is very close to heart, especially with the current COVID situation, to reduce contact points. This year, we see a spike in interest in our contactless switches and sensors that are suitable for such applications. They are typically used in clean room settings and smart toilets. We recently also see customers using these sensors to control lights, which I have a demo later. Radar sensors in healthcare applications is very new at the moment. It can be used basically for live detection, to contactlessly detect breathing rates and heart rates. They are useful in nursing homes, and even possibly to monitor infants while they are asleep, so as to detect sudden infant death syndromes. In the very recent years, radar sensors have also been found to be applicable for fall detection. This becomes especially important for our aging societies. Next, I have a set of 2 video demos. Okay, the first is using our contactless switch, and the other is with our obstacle detection radar. So here I have a contactless switch in the blue dotted box that tells an AC switch to provide power to the LED lamps in the orange dotted boxes. Okay. So with the wave of my hand, it contactlessly turns on and off the lights. Okay, so here you can see that the lights are turned on, right? And with another wave, okay, it turns off the lights, right? We have also built in some intelligence, okay, to prevent people from switching the lights on and off in short periods of time. Okay. Next, we have a demo of our obstacle detection radar that's mounted on a tripod nearest to you. It has 3 reflectors in the field at 22 meters, 10 meters, and at 7 meters. And you can see their relative positions in terms of range and angle on the radar plot on your right-hand side. The darker the color, basically the higher is the signal, or the larger the signal from the reflectors. Okay, and here you have basically what we have in the field is being reflected in the radar map. Okay, so right far away at 22 meters, the reflector is very small to be seen in the photo, but there's a target there that can be detected by the obstacle detection radar. Okay. So in this video, I will move the reflector at 7 meters around, and you can see the change in positions on the radar map, right? Okay, so I start to move it, okay, and you start to see the dot on the radar map move quite close to 0 degrees, right? And then I'll move it back to the original position again. Oops, I move it closer first. Okay, yeah, and then I move it back to the original position. Yeah. Yeah, so it's now back at 45 degrees. Right. And next we have a very thin signpost at about 9 to 10 meters. There's a signpost without a sign. And we'll rotate the sensor. We can't move the signpost. Okay, so we are going to rotate the sensor, okay, about 180 degrees side to side. And you'll be able to see how the position changes with the rotation on the radar map. Right. So as I rotate the sensor to the left, the signpost is now on the right-hand side of the sensor. Okay, and as I rotate it back, okay, it goes back to 0, and then goes back to the left of the sensor. Okay. And so I've come to the end of my presentation on radar sensors. I hope you have found it helpful. Okay, do reach out to us at our virtual booth for more information and more demo videos of our other sensor products. We have lots more of other sensors available at www.agilesense.com. If you'd like to discuss on any sensor requirements, do drop by our virtual booth or even drop us an email. And I'll be available throughout the live Q&A, and you can reach out to me then. See you.